Good evening. It's not the 15th of July, is it? Yeah, it is. Sorry, it's 15th of July, 2014. My name is Michael Port, and this evening we have Mike Brown, who's going to be presenting and getting us to drink from the DRS and HA fire hose. I think this is the last in our series of webinars for the VCP track. And without any further ado, I'm going to hand you over to Mike to tell us everything he's going to tell us. So Mike, over to you.
Great, thanks Michael. So hello everybody, my name is Mike Brown. I'm coming to you from Missouri in the US, and thanks for having me. So I've followed the VMware crew for a couple of years now, been on the Twitters, learning along with everybody else, connecting with everybody, and I'm just real happy to be here. So real quick, a little bit about myself. You can find me online at virtuallymikeb on the Twitters. I also blog a bit at virtuallymikebrown.com, and as most of us bloggers know, sometimes I find it hard to keep up with the blogging. You can also find me on LinkedIn, as always. So here's a little bit about myself and why you should really listen to me. I am certified a VCP at the 5.0 level. Also have a few Cisco certs specializing in the data center arena, in particular UCS and Nexus 5Ks and below. I'm also a NetApp guy. I really enjoy that. And recently, I'd like to share, I was excited to be an author, but of course, VMware canceled vCenter Server Heartbeat, which is what I was writing about. And so right now, I am not an author. I'm not going to be an author. So I'm kind of bummed about that. But again, glad to be here, and I hope this is helpful to some folks. Okay. So right off, we'll kick it off. Of course, we're going to follow the blueprint. The latest version is 3.4, and there's a link there. I assume the slides will be available for download later, but there's a link for everybody anyways. Now, even though HA and DRS really are shown in the blueprint in Objective 5, and in the blueprint it's even shown as 5.x, we're not going to cover each and every item in this particular objective, but most of them, because those particular ones are associated with HA and DRS. And here's what we're going to cover. I won't talk about this slide too long, but to give you an idea of what we're going to cover. There it is. And we'll just jump into it. I have demos added into this as well, so we can kind of see what 5.5 looks like if you haven't been in there yet. I'm going to keep this at the VCP level as much as I can, just to give folks an idea of what to expect, say on the test, because that's where a lot of the folks listening will be aiming for, right? To learn what they can in order to pass the exam. When I can, I'll also add in useful things that you may see out in the real world, so it's not just strictly exam related. So first off, we're going to talk about the objective being able to describe DRS virtual machine entitlements. In this case, when you hear of entitlement, you need to think DRS. Not to read the slide for you, but the idea is that entitlement is going to, it refers to how a virtual machine gets its resources allocated. There's two different kinds of entitlement, as you can see. Static being user-defined. When we talk about static entitlement, we mean those things that users change, like shares, limits, and reservations. Shares, limits, and reservations are hit hard in the test, I believe, at least in my experience, which, by the way, I should say I haven't taken the 5.5 exam. This is all based on documentation available online that you should definitely check out. And dynamic entitlement, which is vSphere itself between vCenter and the ESXi hosts, pulling metrics and figuring out exactly how much or how many resources the virtual machine is asking for, and therefore how many, or not only how much it's asking for, but how much the system has to allocate. I'll say first that the diagrams here did come from Duncan and Frank's 5.1 book, but this is essentially unchanged from, at least the diagrams, unchanged from 5.1. I added a few other links here that you should definitely check out. For folks new to VMware, if you haven't read Duncan and Frank's clustering deep dive books, now they don't have one out for 5.5 yet, but if you still haven't read them, you really need to keep an eye on them and keep an eye out for 5.5 coming out if they're going to write one. But at least check out the 5.1 book. It is really your Bible for VMware clusters. As always, you need to be reading the documentation, the VMware documentation itself. That's it's going to be your best bet when it comes to knowing the material to pass the test. And I listed the performance best practices for 5.5 as well. It's more of a deep dive, but if you have the basics down and want to get some more into how the hypervisor does its thing, you'll want to read that. With regard to the diagrams, the diagram to the left shows how dynamic entitlement and really how the virtual machine's resources get allocated entirely, not just from its dynamic calculations, but also from the static calculations, which we can see down here, the reservation shares and limits. A couple of things to keep in mind: the dynamic entitlement comes from what the VM is actually using with regard to CPU and memory. The two metrics that it pulls to determine the two metrics that vSphere uses to determine how much CPU the VM is requesting are percent run and percent ready. Percent run is exactly how much CPU a particular VM is using when this metric is pulled, and percent ready, I'll say now, is one metric that you're going to see again and again and again, not just on the test, but in job interviews, if you administer vSphere environments at all and troubleshoot vSphere environments, you're going to see percent ready come up again and again. So really understand percent ready. It is the amount of time in percent that a virtual machine is ready to execute instructions, but it cannot get time on the CPU. The hypervisor won't give it time because the hypervisor is busy servicing other instructions. A high CPU time, a high percent ready indicates that you may have a CPU contention problem. So it takes percent run, the actual amount of time that a VM is running, adds in the percent ready to determine how much CPU a VM is actually asking for and using. With regard to memory, the active memory refers to, this is also something that gets confused often, active and consumed memory. The active memory is essentially the active working set of a particular VM, how much memory that has been or is in use at that moment. The idle consumed memory refers to the amount of memory that VM has touched, but is obviously hasn't touched recently, right? That's the idle part. The times 0.025 says that they add 25% of the idle consumed memory for peaks or bursts, right? And then, of course, memory overhead. Running a virtual machine on a hypervisor consumes some memory from the hypervisor itself in order to run that machine. So it takes those three metrics then to determine how much memory that particular VM requires, and that's called active memory. So active CPU and active memory together will determine the dynamic entitlement for a VM. But it's not just dynamic entitlement, right? Obviously, we have to take into consideration what the administrator has configured with regard to reservations, shares, and limits. Now would be a good time to talk about those three, of course. A reservation, then, is the minimum guaranteed amount of resources, either CPU or memory, that are guaranteed to a particular VM in all circumstances. Whether there's contention of that resource or not. So no matter what's going on a particular VM, you can, we're talking about VMs here, but this reservation shares and limits can still be set at the resource pool level. But with regard to entitlement, these are on a per VM basis. So a reservation, minimum amount of resources guaranteed to a particular VM. Shares. So shares, well, let me go to limits, I guess, just because reservations limits are kind of polar opposites. So if the reservation is the minimum amount of resources guaranteed, then the limit is the maximum amount that a particular VM can use of any resource, right? In this case, we're talking CPU and memory. Now, there is a natural limit. Of course, I've seen this not misidentified, but some folks may have a hard time distinguishing. The hard limit or the natural limit of a VM to use a certain amount of CPU or memory is, of course, its configured amount of CPU and memory. So if you have 4 gigs of memory configured for that VM, the natural limit, without even expressly or explicitly setting a limit on that VM, is going to be 4 gigs of RAM. Now, that's not taking into consideration other factors, but the idea is if you configure it with that amount of RAM, that's how much it has to use. Same with CPU. If you give it 1 vCPU, it's not going to use more than 1 vCPU, everything else being equal. But a limit then will artificially limit or put a maximum or put a cap on the amount of CPU or memory that a VM can use. So knowing that, we can see that it doesn't make sense or wouldn't make sense to set a limit equal to the configured amount of resources. So if you have 4 gigs of memory configured for a VM, it wouldn't make sense to configure a limit of 4 gigs of memory, right? That limit's already there by way of having that VM already configured for 4 gigs. Same with CPUs. But if you had a VM configured with 4 gigs of memory and you put a limit on of 2 gigs, then that would, no matter what else is going on that particular host, that VM will not be able to use more than 2 gigs of memory. And similar idea is with the vCPUs. And shares. So one important thing at the VCP level to understand about shares is that they're relative, right? They're relative to their sibling, and then that also determines how much is available for the child associated with that particular share, okay? There are some the default shares of high, medium, and low, but the idea here is that they will change, and we'll get into this a little bit later. The shares will change depending on what other sibling shares there are, right, or at the same level, right? So if you have 2 VMs running on the same host with no resource pools, you just create 2 VMs and use the default shares. Each VM is going to have a normal amount of shares, and during contention, those shares will take place. Those shares will come into play, I'll say. This ensures that each item or each VM or resource pool will have a configured amount or the default amount of resources to run during contention. And again, we're talking about CPU and memory. There's a similar idea with storage DRS, and we'll get into that as well a little bit later. With the idea of having shares and limits applied. The diagram to the right just shows that another important concept with DRS is that it's while vCenter works with the hosts to make DRS happen, right? DRS scheduling and determining this dynamic entitlement target, it's a vCenter function. And so you can't utilize DRS without vCenter, okay? This calculation is done on vCenter, but of course it's calculating all these things across the cluster, right? DRS has to operate in a cluster, same with HA. But a cluster is comprised of discrete, disparate hosts. So when it pushes down these this final allocation, taking into consideration the actual amount requested of the resource and artificial limitations put on that, each ESXi host then has to determine how much resource it has of that particular, in this case, CPU or memory, and how much it can give to the VM. Right? It's they work together, but DRS in the end is a function of vCenter. So a few quick questions. We'll just kind of run through and see if we learned anything. What happens when a new VM is powered on at a sibling level where shares are allocated? And remember, even if you don't explicitly configure shares, there are default shares, right? Normal, low, and high. So even when you don't configure those explicitly, they're still there. Do we have anybody that cares to answer? A lot of folks probably already know this, but anybody on tonight that would like to take a stab at this?
Sorry,
okay,
Mike. I think everyone's
So,
on mute, unfortunately. So
shares
they couldn't answer.
Okay, no problem. Okay. So the priority of all other siblings will change based on the additional shares. Again, shares are relative, and whenever there's a change at that sibling level or underneath it, these shares, or the shares applied to a particular entity, a VM, will change. It's all relative, and with regard to the VCP, you have to keep that in mind. So let's just take one ESXi host for an example. There's 10 gigs of physical memory on this host, and say there are 2 VMs created to run on this host. No resource pools are created. So the VMs, say they're configured each with 5 gigs of memory. Let's just use round numbers to make this easy. So without contention, right, if both VMs are running, say, are actually utilizing only 2 gigs of memory, there's no memory contention on the host, right? There's 10 gigs on the host. Each VM has 5 gigs. Each VM is only using 2 gigs. There's no contention. What if one VM, well, let's say both VMs start using 5 gigs of memory, then they're using essentially all the memory that the host has. We're fibbing a little bit here, fudging the numbers just to make it work, right? But they're going to have that artificial limit placed on them. They're only going to be able to use, I said artificial, the natural limit of the configured memory. They're only going to be able to use 5 gigs each. Say you add a third VM, okay? That VM also has 5 gigs of memory configured, but there's only 10 gigs of memory on the host, right? Now you're oversubscribed on memory, but each VM thinks it has 5 gigs of memory to use. Because of the normal priority, the normal shares that each VM has, each VM then essentially has an equal opportunity, an equal share to the physical memory of the host. So should memory contention occur with these 3 VMs, at most, if they're all utilizing the same amount, or if I say the same amount, if the memory on the host does find itself in contention, then each VM will be limited at the same rate. So in this case, 3 1/3 gigs of memory will be allowed for each VM, okay? Because they're all at the same share level. Neither or any VM, none of the VMs have more shares than the other, right? The idea is it's all relative. And what are the default reservations for virtual machines? This is something you may very well see on the test. The idea is that without any static entitlements, shares, limits, or reservations, or in this case, reservations, right? The default reservation is going to be 0, right? Without adding a static reservation, your reservations will be 0. So if you add a, say if you have a VM configured with 4 gigs of memory, and you add a reservation of 2 gigs to that VM, then that VM will then have a 2 gig reservation on memory, but continue to have a 0 gigahertz or 0 megahertz reservation for CPU. Okay, and these reservations we'll get into later also affect some other items in with regard to DRS and HA called slots, right? Or slot sizes. So true or false, VM cannot exceed its VM reservation. Now, of course, that's just by the wording we can imagine that that's a false answer, and that's of course right. The idea being a reservation is not a maximum, right? It's a minimum. It's a guaranteed minimum. At the VCP level, it's this sort of understanding that that you'll need to get straight, right? At least understand at this level. So it's the limit that a VM cannot exceed, and if an artificial limit's not placed on that, on a particular VM, then its sort of natural limit is its configured amount of resources. Okay, and I think I just gave this away, right? So true or false, a VM cannot exceed its limit. Now that makes more sense, right? Cannot exceed its limit, but it will always be guaranteed its reservation, right? So no other VMs can step on or use those particular resources. That VM will always have its minimum, the minimum amount of resources configured for its reservation. And a default limit on VMs. Now, so here's why I put the asterisk on this, or the asterisk. I've already spoken about it. Yes, it's unlimited, right? But really, in reality, that limit is going to be the configured amount of resources, right? 2 vCPUs. If that's what's configured, then it's not going to be able to use more than 2 vCPUs, even though the host may have 10 or 20 or 40 logical processors, right, or physical processors. That VM's not going to be able to use that many if it's only configured with 2 vCPUs. Same with memory, right? The host may have hundreds of gigs of memory, but if it's only configured for 4 gigs, it's not going to be able to use more than that. So it's a sort of natural limit. Okay. This also, again, I guess I didn't mention it yet, but the idea with more of a real-world tip, I guess, is that you shouldn't mess with reservations or shares or limits unless you really know and understand what it's going to do to your environment. No, you do need to understand the implications of changing these and tweaking these for the test. There's no doubt. But in the real world, I still see folks today that use, say, resource pools in the hosts and clusters view for sort of management or keeping track of their VMs, right? They use it as a folder structure versus using it as a true resource management tool, okay? And finally, true or false, reservations are ignored in the case of resource contention. And of course that's false, right? That's the purpose of reservations, that should resource contention occur, that reservations will be kept, will be honored, right? We want to make sure we put a reservation on a VM to ensure that it always gets at least that amount of resource. Okay. Another thing to note with regard to reservations are that they only really come into play, they only do their job when there is resource contention. So if you have an ESXi host with 500 gigs of RAM, but you're constantly running at 50% of that, right? You're never, I say never, but if you're constantly running at half that, there's not really going to be a resource contention from memory, or it's not going to be a contention from memory when your VMs are running. Memory reservations then, in that case, won't come into play. Many times, if you haven't found out already by managing your environments, memory will be the first bottleneck, right? Memory will be the first resource that sees contention rather than, say, CPU, right? We're not taking disks into account right now, or storage, but with regard to CPUs or memory, memory is many times the first resource that runs out, and therefore you may find that maybe your more important VMs may need a few reservations. Yes, all right, so let's move on. So another topic in the blueprint is to create and delete a DRS and HA cluster. So there are really several requirements, but two of the big ones, two of the important ones, include shared storage, right? Now, I know there's the shared nothing vMotion, but the idea is for what the purposes of many deployments, shared storage is going to be very useful to what you do. But most importantly, shared storage means that all your ESXi hosts need to be able to access the same data stores, right? Whether they're backed by LUNs or by NFS data stores, shared storage will be a requirement for DRS or HA clusters. And again, most importantly, when you create a cluster because those pieces of hardware work well together with respect to their processors, right? They're interoperable. I note EBC here because if you want a vMotion in between within the cluster and in between hosts in a cluster, you'll need processors of certainly the same family, and with at least, if you can help it, the same step in that family, or at least have a minimum level with the use of EBC. Enhanced vMotion compatibility is what EBC stands for. Clusters are meant to be able to not only vMotion VMs around, but in the case of HA, be able to restart VMs on similar processors, but certainly to vMotion between them as well. So let's take a moment. Let's go through a demo, if I can here. So here's my work lab. We'll go through a demo of creating a cluster. So again, this is at the VCP level. I'm sorry, I think I clicked the wrong one already. And many folks have already created a cluster and have done so many times. So what I'll do is I'll give it a name. We also have to choose. So of course, clusters operate in a hierarchy, right? There's a particular vCenter, and then virtual data centers within vCenters, which are really all encompassing containers for a virtual infrastructure, which is a virtual data center, right? And then within that virtual data center, there are clusters, okay? And certain things happen at certain levels, but clusters reside within data centers. Yeah, so we'll give it a name after we chose which data center it's going to be in. We will choose to turn on DRS, and we will also choose to turn on HA. Okay. With regard to DRS, we have a few options here we'll get into shortly. We can choose the automation level, which will tell us if DRS is going to run sort of hands-off-ish, fully automated, and do all the work on the back end, or if it's going to run partially automated and just give us some idea of what would help with regard to moving VMs around, and manual, which would only give us suggestions. Partially automated also hits on placement of VMs, initial placement during power on. We can choose a migration threshold. This also is something we'll get into in the next slide or two. Tells us Of course, DRS does all of its calculations on the back end, but the migration threshold lets us choose how aggressively, or essentially how much those VMs will be moving around. Is what you'll see on the back end. If moving VMs, if vMotioning VMs will help a little bit, is DRS going to move them, or will your cluster have to be greatly out of balance before DRS acts on it? That's what your migration threshold changes. And then there's vSphere HA, right? We turn on HA. Host monitoring is what we talk about many times. Probably most of the time when we talk about vSphere HA, we're talking about monitoring the hosts for failure, the ESXi hosts for failures. If you turn on HA, I don't even know if, so you can turn on HA but disable host monitoring. I guess, I've never seen that happen in the real world. I don't know if that would make much sense to turn on HA, but you don't use HA, right, by disabling host monitoring. But there's the probably lesser known and certainly lesser used feature of VM monitoring, and with some new versions of vSphere coming out, App HA as well. They can monitor your VM status as well as your application status. So admission control, we're going to hit on all this in the coming slides, but admission control is a feature of HA that essentially ensures that HA can do what we're asking it to do. It's almost protecting us from ourselves in a way, right? It ensures that we don't power on more virtual machines and use more resources than, well, I'll say power on more virtual machines than HA, power on more virtual machines than we need in order for HA to do its job, which is restart virtual machines, right? The admission control policy is also a very important part we're going to hit on here in the next slide or two. It essentially tells us how, or lets the cluster know how we want it to reserve those resources for an HA failover. And actually, I'll tell you what, as we get through this, I think I failed to mention exactly what, for those that I probably took advantage of that everybody knew what DRS and HA were in the first place. We're several slides in, but let me quickly stop and make sure that everybody's clear. So DRS stands for Distributed Resource Scheduling. And what it does is its main job is to ensure that the cluster is balanced. Of course, a cluster has ESXi hosts as members, and virtual machines run on those hosts. Well, what DRS does is it can, in its best days, I'll say, can move around virtual machines across those hosts to ensure that the hosts are sort of evenly running workloads, evenly running virtual machines. So there's not one host necessarily that is lightly loaded and all the rest are running at 95%, for example, right? DRS will move those VMs around. Another aspect of DRS, probably less important than load balancing, is initial placement of virtual machines, right? When you power on a virtual machine, DRS, if it's fully automated, I think even partially automated, will automatically place that or register that virtual machine on a particular host so that it can load balance right automatically just by placing the VM, and it won't have to necessarily vMotion that VM later on to balance resources. So that's DRS. So those are the big things DRS does. Now HA is, of course, vSphere high availability. HA's most important function is to restart virtual machines on surviving hosts should a particular host fail, right? It protects against hardware failure of your ESXi hosts, right? Even purple screens, right? And I guess it's not just hardware failures, there's many things, right? Not just you. It's not like it only protects if your server goes down, right? But what if your management network goes down, or if a particular storage network goes down? HA can be configured to essentially restart virtual machines on hosts that are still able to service them should something catastrophic happen to a host. right? In most cases, we're talking about a hardware failure of an ESXi host. And all these settings help HA and DRS do what they're designed to do in the best way possible, or at least in the way that is useful to a particular environment. Okay.
Mike,
as I mentioned,
sorry to interrupt you. Just had a comment from Frank Buxel, who's listening, just to say that one possible use case for having the host monitoring turned off but HA turned on is that you might want to do that when you're doing some form of networking maintenance to avoid any false positives with HA, and to avoid having to unconfigure HA completely.
That's right. So you're absolutely right. So that's a good point. In the past, I'll admit I've disabled HA on the cluster and then re-enabled after the fact. But yeah, I like that. That makes more sense. It's more granular, rather than having to unregister the HA agent on each host and then re-register it on all the hosts in the cluster, especially if it's a large cluster. So thank you for that, Frank. That's good. So the other less used, I would say arguably less used feature of HA is VM monitoring and app HA or application HA. VM monitoring will monitor the heartbeat from a virtual machine, in particular the heartbeat that VMware Tools gives off. VMware Tools talks directly to the hypervisor in this case, and if VMware Tools, if that heartbeat exists, and I'll put a little asterisk in there as well, if that heartbeat exists, then the ESXi host knows that the VM is alive and working, right? Or in particular, the operating system of that virtual machine is up and running. Then, again, with the asterisk, if that heartbeat fails, ESXi may not necessarily know exactly what failure it was, but it knows it's no longer receiving that heartbeat, and it can restart that virtual machine on a different host. Okay, App HA goes one level deeper and can monitor applications within virtual machines. Now, up to 5.5, VMware did not have its own application HA service, but other companies did, like Symantec. I think there may be a couple more. Actually, the creators of vCenter Server Heartbeat, Neverfail, they had App HA products as well. But in that case, App HA will restart, or either restart services, or you even eventually could restart the virtual machine if an application failed, right? So yes, so we have host monitoring, VM monitoring. When you create a cluster, you also have the option to enable EVC, enhanced vMotion compatibility. What EVC will do is ensure that any host that you add, or any host in the cluster, meet a minimum CPU level, right? The idea is, with vMotion is that because it's a live migration, instructions need to be able to execute the same as they would on any host in the cluster, essentially, right? And if you move between CPU generations that are not compatible, you may have an instruction, a CPU instruction, that would work fine on host 1, for instance, but when vMotion to another host, that same instruction is not supported. That instruction may not exist on that host, right? And EVC helps you ensure that vMotion can work seamlessly, again, all other things being equal, between all hosts in a cluster. Now, I've seen this as well, where EVC is not enabled on a cluster, and then you find out later that perhaps you may want to enable EVC. Well, it's not easy to enable EVC on a cluster that's running virtual machines. As a matter of fact, you essentially can't. So I suggest you enable EVC as soon as you create the cluster. For instance, you could have a cluster full of particular Intel CPUs, and then another cluster with AMD CPUs. Now, if you're buying hardware the first time, and you can make that choice yourself. You would likely stick with one type of processor or another. Certainly if you're adding hosts to your cluster after the fact, maybe during a hardware refresh, or if you're growing or scaling up or out, you'll want to be sure to choose hardware that meets your EBC level or meets or exceeds your EBC level. Okay. Yes. So the difficulty with enabling EBC after the fact is that virtual machines can't. You're not going to be able to change the EBC level on that cluster after the fact. You'll either have to shut down all the VMs before you enable, which is difficult to do in some businesses to find the downtime to do that. But then vMotioning those VMs, or getting those VMs then moved to a new cluster, if they're not vMotion compatible in the first place, you're not going to be able to vMotion those VMs from cluster to cluster. So let's see. So I'm going to create this cluster real quick. I've enabled HA, I've enabled DRS, and we'll come to these. Options here in a moment. And really, actually, right now, I don't know what level my EBC is configured for, so I'm just going to leave it. And there's our cluster. Now, after creating the cluster, you can move hosts into it. I'm not going to move my existing hosts into it right now, but it's as simple as adding a host in which you would add the DNS or IP address to that host, and the credentials to add the host. Okay, so let's get back to the presentation. All right, if I can find it. All right, so that was our demo. All right, storage DRS. So storage DRS does many of the things that the DRS for CPUs and memory does, or we just call that regular DRS. What it does is it can aggregate what should be similar data stores. So if you have data stores, say perhaps across or on a particular host, or even not a host, but data stores across a particular storage array that offer the same services, but you have many, say, data stores that are similar, you can group those together in a data store cluster, and then configure storage DRS on them that offers similar things that regular DRS does, such as initial placement and load balancing across those data store clusters. So initial placement deals with ensuring that your capacity, right? You have two things to worry about when you're with your data store, or where you place VMs across data stores, and that's your capacity in that particular data store, and then of course the performance that you're going to get from that data store. So initial placement will try to balance the capacity of all the data stores, similar to load balancing CPU and memory usage across ESXi hosts, right? You don't want to load up one or two data stores a whole lot when you have another perfectly fine data store that's empty, right? Storage DRS will be able to place your virtual machines across data stores to balance the capacity out. Load balancing refers then to the performance of a particular data store with respect to IOs or IOPS, right? So it tries to keep, with respect to latency, excuse me, it tries to keep latency below, at least by default, it's configurable, but by default 15 milliseconds, okay? Much like a vSphere cluster with DRS enabled, you can put data stores in maintenance mode, which will clear them off, which will storage vMotion virtual machines off of a particular data store so you can perform maintenance on it, whether that's adding disks, or if you're decommissioning a data store, you can use data store maintenance mode that comes with storage DRS to perform those actions. And again, same with a vSphere cluster and HA. You can configure affinity rules with data store clusters, excuse me. Affinity rules will say, hey, I have 2 VMs, and much like you would keep those separate in an HA cluster because they need to stay highly available, you could separate those VMs across different data stores as well. Maybe those data stores are across 2 different storage arrays in the same data store cluster. If a data store goes down, you don't want to lose both of those VMs that need to be highly available. Say, for instance, maybe your domain controllers. It's pretty common that you'll have at least 2 domain controllers in an environment. And if you don't want those, well, number one, you won't want those on the same host ever. So you'll create an HA affinity rule to keep those VMs separate and on separate hosts. But if you're using storage DRS, you can also tell storage DRS to keep those VMs on separate data stores. Should a data store go down, you're not going to leave, or you're not going to lose both VMs then. Okay. So what are the defaults for utilized space in a data store cluster? Default is 80%. So DRS or storage DRS won't won't automatically place a VM on a data store, on a particular data store, if it's over, or if it's at or over 80% capacity, right? It'll find another data store to put that VM on. The I/O latency threshold by default, and again, these are configurable. You're not stuck with these. If a particular data store has a high latency, say over 15 milliseconds by default, storage DRS won't place that VM on that data store. It'll try to find another data store that has less than 15 milliseconds of latency. And finally, the storage vMotions are expensive, right? They can take a long time, and it has to be a reasonable move in order for storage DRS to move, or it has to be a reasonable gain, right? Performance gain or capacity gain in order for storage DRS to implement those changes. And so the algorithm runs every 8 hours with regard to storage DRS load balancing. Okay, these are all things that you'll need to keep in mind for the test. Historically, anyways, VMware has been sort of I don't want to say number crazy, but these sorts of particular questions about statistics or maximums or minimums, in this case defaults, have been used. But either way, you should be familiar with at least the defaults. All right, so let's see. Let's do another demo. So let's go to data stores. All right. Let's create a new data store cluster. There we go. We're going to turn on storage DRS. Okay, so no automation would at least give you initial placement, but the automated level will, or the fully automated then will make those storage vMotions for you, right? So here we get to choose whether we use the I/O latencies to move VMs. Oh, that's the other thing, right? For load balancing, right? If a data store exceeds that latency limit, that 15 milliseconds, that's when the load balancing algorithm will kick off and move virtual machines around until that latency goes down, or maybe move those VMs to a data store that does not have those latencies. Again, by default, the utilized space is at 80%, and 15 milliseconds seems kind of low to me, right? but perhaps I guess I'll say VMware will tell you too, right? Those numbers have been carefully tested, and the conclusion was that these numbers are good. But it may not be for your environment. You can change that here during the creation of storage DRS data store cluster. So let's see. I want this host or this data store cluster to be available to the one cluster I do have, and these two data stores are similar in the type of storage that's backing it. So another, I guess, while I'm choosing these data stores, it might be useful to say that it only makes sense really to add data stores into a data store cluster that are similar, right? You don't want to put, say, let's just use an extreme example, right? You don't want to put an SSD data store in with a SATA data store, right, or a nearline SAS data store, right, slow disks, right, because those VMs are going to be moving around in between that data store cluster or within that data store cluster, and it doesn't make sense, right? You can use data store clusters as not just, look, vSphere is a foundational tool, right? And these data store clusters can be used for the hosting of virtual machines at tiering well, it can be used for tiering virtual machines, giving them, say, gold, bronze, and maybe premium levels of service and support or performance, right, and capacity. So try to keep your data stores similar when adding them to data store clusters. And finally, we get to review what we've done. All right, we see the task as completed, and we see our data store cluster. At least the move itself, or the creation itself, is pretty simple. And choosing that data store cluster, we can see more about it. Tells us we have not only the latency configured, but obviously the load balancing is there as well. Okay. All right. We have a little bit. Let's get back to the. All right. So slot size. This relates to vSphere HA, and in particular the well now, pardon me. Well, I forgot my terminology. Here, I'll get it right here.
Whilst just getting there, Mike, we've had a comment from Joel just to exercise caution with your storage vendor as and the use of storage DRS, as some of them do snapshots in slightly different ways that can be interfered with by storage DRS. So always worth doing some experimenting before you do this in a production environment, just as an aside.
Absolutely, very good. No, it makes sense. Pardon me, so slot size refers to a particular use of, boy, I'm sorry, gentlemen, I forgot my terms. Mission control policy, excuse me. So let's see if we can see that here. I need to open it up on one of these just to show you anyways. Okay, so, well, we have, pardon me, mission control policies, yes. All right. So when we enable HA, we're telling it that we want it to restart virtual machines should a host fail. but it can only restart those virtual machines if there are resources in the cluster, ESXi host resources, to restart those virtual machines. And there are 3 different ways to ensure that those resources are available should a host fail. Number 1 is to define a failover host, right, or hosts. This essentially will not run virtual machines on a identified or dedicated failover host, right? You'll essentially have a host sitting there waiting for another host to fail. It's not running virtual machines. It's not running workloads. It is a failover host. Now, slot sizes come in when you I'm sorry, static number of hosts. The dedicated failover hosts is below. It's where you can identify a host as a sort of standby host, right? Slot sizes then are identified by defining how many hosts worth of resources you want to reserve, right? So in this case, we say I want to be able to fail. I want 1 host to be allowed to fail in my environment and still be able to run all my virtual machines. Well, the best way, the most fair way to ensure, I guess the safest way is probably the best way to put it, safest way to ensure that those resources are available to restart any failed virtual machines in your cluster are to use slot sizes. Slot sizes talk about the worst case scenario, right? Having to restart the virtual machine with the largest amount of reserved CPU and the largest amount of reserved memory, right? Before we talked about, in the early slides, we talked about reservations, right? And reservations severely affect or greatly affect your slot sizes, because slot sizes are calculated by using essentially the largest reservation of a particular resource plus its overhead to run. Okay, so if you have a VM, if you could be running 50 virtual machines, but if you say you have say you're running 50 virtual machines in a cluster, but you have one maybe large SQL server that somebody said, I want to guarantee that my SQL server gets 10 gigs of memory, right? So I put a reservation on that SQL server, and now that reservation has a 10 gig memory reservation. If you're using this defined failover capacity by static number of hosts, your slot size is going to be, at least with regard to memory, it's going to be 10 gigs, right? In a similar way, that's the case for CPUs. That maybe that very same SQL server has a reservation of 4 vCPUs. Your slot size is a combination of the largest vCPU reservation and the largest memory reservation put together, and it's treated almost as one VM, essentially. So a slot size in this case is going to be 4 vCPUs and 10 gigs of memory. That being viewed as a VM, I'll have to show you here. Slot sizes. Oh, I didn't configure it here. I wanted to configure it here. I'm sorry. Here. That largest VM is going to be essentially divided into the total number of resources you have in the cluster, and then tells you how many slot sizes you're going to have available, or how many slots you're going to have available to restart virtual machines based on the largest reservations you have in your cluster. Okay, so let's configure this slot size. I want to show you how changing your reservations, well, I guess I can't do that without VMs. vSphere 5.5 did give you the ability to actually, in this case, I gave you an extreme example, but it's the example that prior to 5.5 gave us the most trouble with slot sizes. The idea that you have one VM with large reservations that totally messed up your slot sizes and affected how many virtual machines then you could restart should there be a failure, or how many VMs were restarted by HA should there have been a failure. But now you can use a fixed slot size, right? You can sort of manually say, hey, I know I have this one outlier or maybe a few outliers, but that's nothing I want to affect my slot size. You can configure manual slot sizes then in this way. All right. Let's just do that. All right, so migration thresholds. Another task in the blueprint is to configure migration thresholds. So let's identify what that is. Migration threshold determines which recommendations are generated and applied. This is what we configured when we first created the cluster. It's essentially when does DRS kick in and start doing its thing, right? This has to do with whether load balancing is fully automated or partially automated or just manual, right? So in the three different levels, if you recall back in the cluster, I guess we can just go here. So we had, by default, it's set at level 3, right? It's set right in the middle, where level 3 conditions are moderately aggressive, right? The idea is DRS will do its background calculations for load balancing, and it will apply everything that will enable or will offer a good improvement to the load balance of the cluster, right? You can turn it down to where you only move virtual machines, say, if you're putting a host into maintenance mode, right? Or you can turn it up to the right, if you recall, and set it to be aggressive, where it says even slight improvements to the cluster's load balance will kick off vMotions, right? And that's fully automated. The idea is you're asking, how often do I want to see vMotions in my cluster? How much imbalance am I willing to take? How much imbalance in my cluster with regard to CPU and memory usage am I willing to take? If you have users that are sort of, or say application owners or end users that are picky about seeing their virtual machines move around or something like this, perhaps you're being forced to turn this migration threshold down, or even almost off. Say off, but the idea is it only kicks in when you have to put a host in maintenance mode or something similar. This is your migration threshold. Okay, partially automated will then it will let you let DRS place virtual machines on hosts when they're powered up, and then further, the partially automated will only suggest if virtual machines, if performance would be improved or balance would be improved, if virtual machines could be vMotion around. It will give you those suggestions and then let the administrator determine whether to take those suggestions or not. So this link is for vSphere 4, 4.1 perhaps, but it's still relevant to calculating the priority of DRS moves. Automation levels we just touched on. The idea here is to vSphere and DRS have been around long enough that it's been proven, right? People sometimes, at least in the past, may have freaked out a little bit or been uncomfortable with their virtual machines moving around without their express actions. Well, again, being in production with some of the largest and most important businesses out there, vSphere has proved its mettle, and so has DRS. And so the recommendation today is to use fully automated. Just start it from day one and let it go. There's no real reason necessarily other than to sort of maybe give you a warm fuzzy to not use fully automated. Now there may be particular use cases and whatnot, but the idea is for the most part, fully automated works just fine, and you should have faith in it. Okay. So admission control for HA and VMs. Again, this is similar to what DRS was. DRS being a vSphere function. Actually, admission control itself is a vCenter function. It tells the hosts how many resources need to be reserved. Pardon me. So in this case, it calculates the slot sizes, and it knows how many VMs or how many slots then will be available on the hosts, and it also then tells the hosts how much to reserve in the case for admission control. Now, sort of a real world case then for understanding defined failover capacity is that you should size your ESXi hosts similarly within a cluster, right? A similar amount of CPU, a similar amount of memory especially, right? Because again, memory is some of the first to be constrained. But if you size them similarly, then the same amount can be reserved on each host versus having 25% of a huge host be reserved and then 25% of a smaller host being reserved. This can cause issues when HA restarts, or if HA does restart VMs. DRS would have to work with it if these hosts are dissimilarly sized. DRS will have to move some virtual machines around in order to, or DRS might have to, move some virtual machines around in order to restart all those virtual machines. Again, because the hosts were not sized similarly, and there's not perhaps not enough resources available to restart those VMs. We touched on admission control policy. So here's some advantages and disadvantages, I guess, to each one. The host failures cluster tolerates. We have the slot size issue that you have to keep in mind, right? If you have large reservations, which is another reason to use reservations carefully, you may have slot size issues. Now, the manual or the manual override, I guess, for slot sizes is available in vSphere 5 as well. I'm sorry, 5.5. So you can use that. The percentage of cluster resources reserved. This is most flexible. This option. Now, this is I'm stealing this from Duncan Epping, of course. He wrote a nice blog post on this. The idea is you don't have the restrictions of slot sizes, and if the hosts are sized similarly, then DRS won't have to work extra to move those virtual machines around. It just reserves the 25%, or I say 25%, but however many hosts that you are protecting against failure, right? N+1 or N+2, it will reserve. You need to figure out that percentage, right? If you have 4 hosts and you want to protect against one host failing, then 25% here makes sense for both memory and CPU. If you have one host out of 8 you want to protect, then perhaps 13% of resources you'll want to use, right? And dedicated failover hosts, as we mentioned, it's just essentially one host in a standby state. And it's not standby per se. The idea is it's just not running VMs, and that's because of this setting, right? So it's expensive in the idea that you have a host sitting there not running any workloads. So, but then this expense, say with the percentage of cluster resources reserved, is spread across all the hosts because you're not using a certain percentage of those hosts to run virtual machines. You're reserving those resources for the event of a failover. Okay? So we're close to the end here, gentlemen. How are we doing on time?
We're a little bit over the normal hour, but don't worry about that. That's all good stuff.
All right. So wrapping up here, or at least we're about a couple slides away. One of the final points in the blueprint is to determine an appropriate failover methodology and required resources for an HA implementation. So the idea is, how can, if you were asked to design an HA cluster, what would you have to consider, right? Obviously, you would want to choose or right away, you want to choose an HA admission control policy. This is how, going back, how many hosts do I have? How many hosts do I want to protect against failure, right? Are we doing N+1? Are we doing N+2? What are the implications of reservations in the environment, and how does that affect my slot size, right? If you have some monster VMs that have some big reservations, maybe they get their own cluster. Maybe you don't put those VMs in, say, the general purpose cluster. Or maybe you have management that is bent on having failover hosts for whatever reason. Many times we can't always get what we want, and so we get overridden, and maybe you'll have to go with a dedicated failover host or two. But perhaps if you have your way and you're smart, wink wink, you'll use the percentage of cluster resources reserved, right? And you won't have to mess with slot sizes. You won't have to do that calculation. You'll just do a quick calculation of hosts to protect against failure, and divided by the number of hosts you have, and it'll tell you how many resources to reserve. Okay. The recommendation again is to use similarly sized hosts in your clusters. This matters because if you again have that one large host and you tell it to reserve 25% of resources or however many, if you use the smallest host, if you use the smallest host and you have a large host in there, you're not going to have enough resources. You want more than enough resources in order to restart your VMs. So use similarly sized hosts. This is what I was talking about, fragmentation, resource fragmentation. I, again, forgot the term, but the idea is if you don't have all of the resources on one host to restart a particular number of virtual machines, DRS will vMotion machines around in order for those virtual machines to be restarted. And this is again if you have dissimilar hosts. Okay. Just as a recap, use percentage-based if you can, just for its flexibility. Reservations, you want to use those carefully. I still see this again today, reservations and limits and hard shares. Be sure you understand the implications of using all of those static allocation methods, okay? And avoid using advanced settings. The idea here is that it's not to say you not to use them, but it's to say don't make your vSphere environment more complicated than it has to be. Yeah, I'll leave it with that, gentlemen. So, yeah, I've already mentioned on this, EVC. Just be sure you enable it before you create the cluster. Many times it's hard to get that sort of downtime to move to an EVC-enabled cluster. Okay. Yes. So distributed power management, didn't even get a chance to talk about that much, but the idea is it will work with DRS. So if DRS needs to move some VMs around, they can pull hosts out of standby and move those VMs. Now, there was the idea that templates aren't moved here. So if a host wants to shut down via DPM, it may move those VMs off of the host. I said to move the VMs, but it's not going to move your templates off. So I guess that's more of a gotcha with DPM. You may want to keep templates on a host that isn't turned off. Just be careful of that, right? Because if you want to go deploy VM from template and it's if it's registered to a host that's turned off, it's kind of a pain. And affinity rules. So affinity rules are going to be useful if you need to keep VMs together or separate or running on particular hosts. Recently, with the uptick in talk about management clusters, a big thing I've heard for reasons to have a management cluster is that if you have enough virtual machines and enough hosts, you have a hard time finding your management VMs, right? Certainly vCenter, right? In the database that your vCenter runs on. If you don't know where those are, you may just want to create a management cluster so you always know where those VMs are. You don't have to go one ESXi host at a time to try to find particular VMs. We talked about domain controllers being kept on different hosts and on different data stores. Or if you want to keep virtual machines together, right? If you want to keep an application stack all on the same host so that they don't have to necessarily send traffic over the network, they can all operate on the same host. For best performance or something like this, you can use affinity rules for that as well. And finally, VM and application monitoring. One thing I didn't mention with regard to VM monitoring, I told you there was the asterisk associated with the heartbeat from VMware tools. It does also monitor network and disk I/O. By default, both network and disk I/O are monitored for the last 120 seconds. Should VMware tools not offer a heartbeat to the ESXi host, then the network and disk I/O is looked at, and if there's no I/O, then the ESXi host knows for sure that the VM has failed and it can restart. And this this advanced setting, DAS I/O stats interval, which is 120 seconds, you can configure that to be the same for the failure interval of the VM monitoring. And that just says, hey, if VMware Tools hasn't spoken to me for 30 seconds, then just only look at the last 30 seconds of network and disk I/O for that VM as well, right? Finally, app monitoring. I mentioned that folks have looked at maybe the vSphere 6 beta coming out, and there may be some good stuff upcoming with app monitoring. Maybe we might have a native solution for that. There's also third parties out there doing app monitoring, Symantec being one of them. Gentlemen, that's really all I have. I know I went over. Thanks for your time. Does anybody have any questions?
We just had one come in from Jitesh, sorry, just to ask if there's a minimum disk I/O.
You're talking about for VM monitoring?
I think he might be.
In this case, I would say no. I don't know for sure, but the idea is it checks network and disk I/O for any traffic, right? To ensure maybe VMware Tools failed, right? Maybe the VM is operating just fine, but something wonky happened with VMware Tools. If the VM is operating just fine, then network and disk I/O will likely be working fine as well. So if there is traffic, it's just looking for any traffic, right? If there is traffic, it's not going to restart the VM. So the minimum This is sort of like 3 check boxes, right? Do I start the VM or do I restart the VM? Let me go through my check boxes. Has VMware tools checked in? No. Okay. Is there any network I/O? No. Is there any disk I/O? No. Those 3 are no, then it's going to restart the VM. But you can imagine that there's no VMware tools heartbeat, there's no network I/O, oh, but I see some disk I/O, right? Maybe the VM's not necessarily dead. Okay? I hope that answered your question.
Yep, I believe it did. He says thank you. Any other questions for Mike at all? Nope, not seeing anything. Thank you very much indeed, Mike. It was most illuminating, definitely.
Thanks, Michael. You rock.
No problem. We look forward to having you again another time, I'm sure. And yeah, you never know. Might meet at a conference one day.
You bet. You bet. All right, we'll see you on the Twitter.
Yeah, indeed. Thank you very much, everyone. Next week.